Okay, let's talk about measurement. I have a few examples that I would like to comment on. Let's begin with this ruler, which is able to measure inches or centimeters. And we have it placed on our object so that it's measuring centimeters. Our object is a disc, and we're measuring the diameter of that disc. So the first thing I'd like to point out is that centimeters is broken up into tenths on this measurement device. So we can read this as 4 centimeters, 4.1, 4.2, 4.5, 4.9 centimeters. And it looks like that's the diameter here, 4.9 centimeters. But we can introduce one more level of precision by a process known as interpolation. So if we zoom in, which is something we can do with cameras, and we look really closely, we can see that this doesn't quite touch the 4.9 mark. It falls short of it. So we can interpret another level of precision, and instead of saying that this is 4.9 centimeters exactly, we can say it's 4.89, meaning 9 parts of the way to the next mark. You see there's space between these two marks, and we can interpret what that space means. So for example, if the edge had been right in the middle, we could have called that 4.85, but it's very close to the edge, so we would say 4.89 or 4.88. But another thing you notice is as we've zoomed in, the lines appear thicker. And because they have thickness, what does it actually mean to be exactly on the line when you're taking a measurement? Does it mean to be at the edge of the line, the middle of the line, the far side of the line? And so this is telling us that this measuring device has a limit to its precision, and there is some uncertainty in exactly what a numerical value should be. Here is a hair. It's actually one of the hairs from me, and I placed it on a microscope slide. And on this microscope slide, there's built in a ruler. But this is the tiniest little ruler you've probably ever seen, because one division in this ruler is 1/100th of a millimeter. Now, just to remind you, a millimeter is what happens when you take a meter and divide it into 1,000 smaller divisions. So 0.01 millimeter is going to be the same as 10 micrometers, or 10 over a million of a meter. Here's a quarter to give you some idea of scale. This is what my hair looks like under a microscope. Here we have a hair on top of that teeny tiny ruler under a microscope. So we've actually zoomed in so that we can see the divisions of the ruler. This would be 0.01 millimeter, 0.02 millimeters, 0.03 millimeters, 0.04 millimeters, 5, 6, 7, 8, 9, 10. It looks like this occupies about 0.05 millimeters. But notice that the edges are blurred. And it's hard to tell where this hair actually begins and where it ends. Now here we'll watch a little film of focusing the hair and the microscopic ruler. I'm going to play that again. Notice that because we're dealing with such a very, very small scale, and we're looking under a microscope, it's not possible to have both the ruler and the hair in focus. We can have one of them in focus or the other, but not both at the same time. And this is a limit of our optical microscope. When you have limitations to your instruments, as you always do, this is what introduces uncertainty into your measurements. Now here is a penny, and it's been oxidized, so you can see that it's copper because the oxide is the color of a copper oxide, a copper carbonate hydroxide oxide, but it's that beautiful blue-green patina that you often see on the outside of copper statues. It's also on the outside of the Statue of Liberty. Beautiful color. But this was at one time a shiny penny, and you can see by the fact that I've scratched the surface here that the copper does show through. Now the grid here, each square is 5 millimeters. So we have 5 millimeters, 10 millimeters, 15 millimeters, 20 millimeters. And if we do some interpolation, so if we're measuring the diameter of this penny, if we do some interpolation, we can say that it's, okay, 5, 10, 15, 20, but not quite 20. So we could say 17 or 18 millimeters of diameter here. And we would not be exactly sure because we can always interpret one place more than the markings actually give us. But that last place has uncertainty in it. This is a burette, and it's filled with a liquid. And what we're measuring here is no longer length, we're measuring volume. And each mark on this burette represents a milliliter. Just to give you some sense, 5 milliliters is the same as a teaspoon of liquid. So, and there's 28 milliliters in an ounce, if that's easier for you, a fluid ounce. Okay, so the first thing we have to notice is the direction this scale is written. So it's increasing as we go down. So the level is somewhere between 24 and 25 milliliters. And to read this correctly, we have to count from the 24 mark. And this curved surface is what happens when you put water inside a glass tube. See, water is more attracted to glass than it is to water. So it actually creeps up the sides and forms this curve, which is known as a meniscus. So by convention, we decide to read the bottom of the meniscus, and that's this point right here. So we have 24.1 milliliter, 24.2 milliliters, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, 25 milliliters. So we're at 24.2 milliliters. But again, we're not there exactly. There's a little space between the bottom of the meniscus and this mark. So we can interpolate a figure. We can call this 24.19 milliliters. Again, we go one figure past what the marks actually show to get our last figure. And that figure, of course, has some uncertainty. So one student might see it as 24.19. Another student might interpret this as 24.18. There might be some disagreement in that last figure. We could indicate this by saying plus or minus 0.01 milliliter. Plus or minus 0.01 milliliter indicates our uncertainty in this reading. I put this here for fun. We've been looking at things which are very small, but we can also measure objects which are quite large. And I just love this picture. It's one blade of a wind turbine. It's about 36 meters long. That's about 120 feet. And here they are trying to get it up a curved road. So we've been using the metric system. Let's review what some of the words that we've been saying are. So several times I said the word centi. Centi comes from a word that means 100. And in this case, it means 100th of a meter. In other words, you take a meter, you divide it into 100 parts, and you get a centimeter. But this same root is used in other words you might be familiar with, like a cent, which is 100th of a dollar, or a century, which is 100 years. So centi, in this case, means the fraction 1 over 100. Milli, when we were talking about the hair, milli is a thousandth of a meter. So take a meter and divide it into 1,000 parts. And micro is a millionth of a meter. So our piece of hair was about 50 micrometers wide, about 50 micrometers wide. Going the other direction, we have a kilo, which means 1,000 of something. So a kilometer is 1,000 meters. And we have mega, which means a million. You can see these prefixes used in ordinary conversation. Customs seizes over 4K steroid pills at O'Hare International. You're expected to know that the K means 1,000, so 4,000 pills were seized. Mega Millions drawing 1 million ticket. So mega here means a million, so $1 million. A ticket was purchased, and some lucky person got $1 million.